afternoon to all the participants. Now here we have an esteemed speaker, Gauri Padmaja, to give a talk on DevOps. She is a senior cloud DevOps engineer from the Singapore Presshold. I Tanandaram to introduce Ms. Gauri Padmaja.
Good afternoon, everyone. So it gives me an immense pleasure to invite you as a guest speaker to address our participants in this webinar on DevOps. So about Mr. Gauri Padmaja, currently she is working as a senior cloud DevOps engineer at the Singapore Press Holdings, Singapore from 2019 to 2019, she worked as DevOps engineer at the Great Eastern Life Festival Limited, Singapore. From 2000 to 2018, she worked as DevOps engineer consultant at DBS Bank, Singapore. To 2016, she worked as a senior DevOps engineer at VST Global for the client T-Mobile USA. From 2013 to 15, she worked as a freelancer. From 2011 to 13, she worked as DevOps engineer tied to in Amazon Development Center, India, for multiple internal services like inbound dock, transportation team, inbound data warehouse team, point of contact in India for any of the above service issues, and part of process improvements. Over 6+ years of experience as DevOps engineer. She having good exposure on setting up CI/CD with various tools like Jenkins, Bitbucket, SVN, SonarQube, Nexus, Bamboo, Docker, Rancher, Cloud Delivery Pipeline, etc. for various in both on-premise and cloud infrastructures. So we hope that, Madam, your thoughts would enable our participants to gain knowledge from your expertise and experience. So now I am handovering the session to Mr. Padmaja Praveen Garu. Please take the session, madam.
Hi all. Hi. Thank you, sir. That's a very good intro. Okay. Hi all. So currently, let's go into the topic, DevOps. And thanks, Satya Garu, because it's good to interact with students like this in order to share my experience on DevOps, and also I feel that it might be fruitful to you in getting your career path in such a way as your interests. So it is good opportunity, I feel, to you guys as well to know what technologies are used in the current IT industry, and also how the interactions would be there between various domains. So it will give you a mindset before you enter an organization. So yeah, I think that's a very good opportunity to you, and as well as for me to get interactions with you all. Yeah. Okay. So yeah, currently I work as a senior developer in the Singapore Press Holdings. So that's based in Singapore. So here I'm working as a senior DevOps. So where I handle my roles and responsibilities are on the same line. Now what I might discuss a bit of here and there, like new technologies I might walk you through. Okay, maybe let's go into the session and I can share you. Just a second. Are you guys able to see my screen?
Yes, sir. Yes, ma'am.
Yes, ma'am. Go ahead, please.
Okay. Let's see what we see in this particular session for the DevOps. So the agenda covers these things: why actually we need DevOps, and what is DevOps, what practices they would use, and what tools that they use in order to achieve those practices, and any guidance that I can give to pave your career along the lines of DevOps. And some here and there, some questions on the things that we learn in this particular session. If time permits, let's have a small tour on the AWS also. Yeah. So before I say why DevOps, can anyone in this particular session can share me your ideas or thoughts that you think that you would do if you get into an IT organization? What kind of tasks or roles that you might think that you would do in an IT organization? Anyone? No? Just to check, am I audible?
Yes, sir, you are audible.
Yes, ma'am, you are audible.
Oh, that's not good. Okay, do not, let's have this as an interactive session. So make yourself free and try interact with me if possible. Yeah. So when I was, okay, let me share my experience. So while I was a student, like an engineering grad, I used to think I used to go, I will go to an organization and I'll code, and just deploy. What is the idea I usually have in my mind? But of the reality. So once you enter into an organization, that's when you IT is. So you see the things that you read on the book or the labs that you being there, but it is still more much advanced that you see in real. Okay, so let's see. Okay, if you analyze a product, so what all will be dealt if you see Facebook or if you see Twitter, how you should think from an perspective like what all teams might be involved, what this Twitter or Facebook or any of the sites would hold at the back for it to show up like this. So definitely there will be several teams that might have been working together in order to achieve that state of the product. Teams like development team, testing team, and also operations team. So let me say you one thing. Okay, so let me say, so development team basically develops the things like write code and generate the design, see design, analyze the requirements, and send it to testers to test the code. So let us see what, just a second. Okay, so DevOps comes in picture because though these many different teams were there, the development team, testing team, and even ops team, team, all were there, but still there is a bit of slowness in the product that is delivered to the end customer. Why? Because they're working as silos. Means what I meant by silos. So the development team, right, they analyze, they build the architecture and they start working on it and they ship their features into one big bundle and let it be tested by the testing team and pushed to the operation team. So this team doesn't be involved how it will be deployed or when it will be deployed. So the roles and responsibility of the developer is mostly related on the design, development, and in conjunction with the testers to test their thing. So they don't know what's happening on the ops end. Because I, as a developer, I test my code. I feel, yeah, it's pretty good on my environment. Then I think it should be working on the production as well. I hope you know what a production environment is, or maybe like give you a quick insight. Environments in an organization, like your local environment is the local environment where you develop your code, you test it locally. There will be another environment like staging or QA environment where it will be similar to your production environment. So you test your code there. If it works, then you push it to production. So this particular team, what in the old days, right? They used to develop, but it doesn't have any visibility how the ops team is deploying, when it will be deployed. Is everything good there? So there is a slight wall. Okay, they think that I've already given my executable to ops. Why aren't they deploying? But ops team, right? They also have several roles and responsibilities. Like they need to see, they need to manage the servers. They need to do patches, and they need to do database backups, and they need to do scaling if required on the server level. So there are n number of workload or tasks on the ops end. since there wasn't a proper communication between this dev team and the ops team before, there weren't none of the dependencies that has to be there as part of the new features that these developers keep building, keep deploying into the ops. Sorry. Okay. So there is no proper communication between these two teams. And previously the deployments, right, whatever the packages are released into production or to the client facing environments, right, they were on a schedule basis. Like once in a month, they used to release all the changes. Means you have teams working on 10 different things. They all wait for this particular schedule to kick in so that they can deploy and ship their things to the, they can host their things onto the product environment. So there was a wall kind of thing between the communications between these two and quite a lot of dependencies. So this way doesn't work much, right? Because I want my things, I want my changes to be fast into the production and be seen by all my end users, give them the feedback, and I need to see if it's good or do I need to do the fixes. So this wasn't there. So that was one thing that delays the process. In the meantime, maybe my competitor might have released certain changes and that was very good in the market. So that might affect my company, right? If my product is not as expected to the user's that requirement. So that is one big problem. And the other one is so the mindset. So I hope, right, you must have heard on the waterfall model and the agile models. So which one do you think that is the best model? Has any answer? Or just randomly? Okay. Okay. So every product, right, will have a life cycle. So right from development till it's given for the release. Means so that all the stages will be same across any of the models, but only how we proceed through one to other stage is the change in the models. But rest all, even agile or the waterfall will have the similar stages. So some say that agile, some say agile is very good to go, but some say waterfall is good. So even till now, we don't have any clear say that this is the best practice that we have to follow. So it all depends on the needs or the requirements that we have. So we choose which kind of model is important. So when both models are good, so what is the need for DevOps? What should DevOps do in this particular changing this mindset or the culture of how we are writing, I mean, shipping our codes right from development to the release? So what is there in this? So I feel that, so for you guys, right, as part of your curriculum, you would have waterfall. Means someone has to get all the requirements in at once. I mean, the requirement phase should be extremely so that they.
Ma'am, sorry for the interruption.
Yeah, no worries.
Participants, please unmute your mic and interact with the speaker. Okay. Yeah, go ahead, ma'am.
Yeah, thank you, thank you. It's good to be interactive, okay, rather than talk. It's good to be interactive. Thank you for that, yeah. So your requirements therefore should be really in so that then you can have a proper planning in your design phase. So the architecture, everything will be properly implemented in the design, then only the development starts. Until unless the design is not finalized or anything, your implementation doesn't start in the waterfall model. So once the implementation of all the modules, suppose if your product is quite big, it has n number of modules. Until unless all modules were verified and there, until the testing of all them is done, it will not be released into your market, into your product market. Already the time that you spend on this particular product has like gone very, very long. So, but by the time, right, all the validations, verifications, the rigorous testing was done on this product and released to the market, the customer might have thought, oh, now I don't see this as meeting my current requirements. It looks quite old. So these things, these challenges would occur for the waterfall model. But whereas when you see the agile kind of methodology, right, you'll have the same development. I mean, you'll have a product, but it will be divided into small chunks. Like you will keep iterating it for some set of time duration, like 2 weeks to 8 weeks of sprint. So basically, you will iterate the modules and keep releasing your product into the market, get the feedback from the customer, and keep improving. Whereas in the waterfall, you just only be able to see your product after the entire phases are completed. So maybe I don't want to go in depth because our concept is we have quite more concepts in DevOps. So these were the things. So the better thing is if you have stable requirements, it doesn't change, like the DRDO, or even if you see any public government-based organizations, right, that have only clear requirements and that doesn't change for a long time, then waterfall is better. But for a fast-moving products, like streaming or like for the e-commerce sites, you need to keep using the changes. You need to engage your customers with the new new product features in the market. So that's where the thought process of agile and waterfall change. So now let's see why we need a DevOps in this particular picture. Since anyways, agile is good, right? I'm getting my feedback back from customer and I'm able to do that and release it in some 2 weeks or less than 8 weeks of sprint. Then why do I need a DevOps? So here, right, there is a gap, if you observe, between your product when it's released to the market to the time you get the response from your customer or from your clients. So this DevOps operations, right, what it does is it ensures by using certain tools and all, it will be able to tell your product how it's in the market, or is there anything that has to be modified in this particular product so it can further enhance its performance. So it deals with certain operations. It looks how it's performing. So all those operations guys would be able to tell you beforehand than you receive it from your customer or from the client. So in this way, right, we can optimize the time that we get a satisfied customer. We can release, and by the time they think, okay, this should have been changed, you would have your fixes there already. So yeah, that's how. So these all things, right, finally why any model arise is to be in a fast pace, in this fast paced world, get your clients satisfied with the requirements, and see your competitors, or you're on your competitors. So any model will look for the client satisfaction or the customer satisfaction. So I think before I say what DevOps is right, what is DevOps, I think the previous slides would have told you the differences there will be addressed by the DevOps. So DevOps, right, it's previously when I mentioned in the other two slides, there is no tool that I mentioned, or there is no program I mentioned, or software or any technology. I just mentioned how it should be addressed, how the mindset should be. So that is DevOps. So it's not a tool or a technology, but it deals with the mindsets. Like it will change, it will help connect to all the parts of your operating model to interact with each other, to collaboratively work, so that you will get a faster release of your products and as well as a satisfied customers. So if you see, right, in the diagram here, the circle one, where dev, operations, and quality assurance combine. So mostly it's a diagrammatic view of what I have just mentioned. So development team and the operation teams in conjunction will help us to give a quality assured products so that we get a happy customer. So that's what DevOps is. If you see the infinity model showcased, right? So in this model, you can see the development phase, the develop plan phase, and the ops phase, like the deliver and operate or monitor. So it will connect all these particular dots to ensure this. It's good, like representing in diagrams is so good. But how do we know, like, how they achieve? What is the plan that DevOps have to achieve all these things? So that's where DevOps practices comes in. Okay, so the DevOps practices, right? We consider mainly continuous integration, continuous delivery, continuous deployment, infrastructure as code, microservices, and continuous monitoring as the main goals that has to be addressed in first place by a DevOps engineer. So ensuring this will ensure a quality product, will ensure a monitored product. So that's where DevOps deals with connecting all the points in the infinity loop. So let's see in detail maybe what these circles present. Am I a bit fast or okay? Okay.
Okay, madam, you can continue.
Okay, cool. So here, right, the continuous integration, delivery, and deployment. What does this mean? Why should I use them? How will they enhance my product speed? Speed release of my product. Okay. Uh, okay. Suppose like consider developers. There might be a team of developers working for a certain module. So these modules, right? So a developer A, I have another developer B, who is we both are working on this same module, same file. So I don't know what the other developer is doing. Rather, he does know what I'm doing. So there is a high chance that I might remove some lines that is present in the code and enhance it to another with some other style. Maybe the other developer does it in some other way. So there might be a conflict when we both merge our codes together and we say, okay, this product is ready to go for the testing. So there will be a merge conflicts. So there are certain source code management tools, the GitHub or the SVN or the code commit that you can use in order to store all your code into it. So that whenever any developer needs to access the code to perform a new assignment, new task, he just pulls it in from your source code repository like GitHub or GitLab or whatever it is. So if I wait, I keep writing my code. Like, okay, next feature also came in. I again keep writing the code. I just increase the number of lines in the code, but I wasn't pushing to the source code repository. So it all sits in my local. So what if someone has pushed and there is updated code in the code repository? I won't be able to roll back all my changes, right? Because what I have done is I have developed quite many snippets. I mean, quite many tasks that were assigned to me already. Reverting back is a difficult task for me. So continuous integration, if it's in place, it will address this kind of issues. Since DevOps goes hand in hand with Agile, it's a practice that developers, whoever is writing the code, for them to continuously keep pushing the code to the central repository so that there wouldn't be any conflicts across the team, provided they do a local testing anyways on their machine provided. So they keep continuously push these changes into the code repo. So that's good. Now my code issues, like there might be quite less, quite less havoc that might be there when a team is big, because I keep continuously pushing. Others who check out the code would have the latest version of the files, and it's good. Now it's going in a good way. But what if this code, right, after build, when it goes to testing, if it fails there? What if it fails there? Again, I need to recode it. I mean, do the fixes and but no continuous integration, right? There won't be testing available right away for me. I need to wait until I click manually something or I assign some tester, please test my code. There won't be any, I won't know what's happening with my changes when it's in the central repo. So continuous integration, when we have done it, it ensures it takes in the code, every push the repo is considered, and it will be built into an executable, and it will be tested completely. So that there will be a feedback to the developers, and via a notification or a Slack or an email, so they would get back and know, okay, that's fine, I'll fix it soon and I deploy. So that's how it goes on with continuous integration. So that's a very important topic. So do not wait until all your tasks were done. Keep pushing the changes once local tests are good into the central repo. Okay, now I'm done, right? So now I'm done with building the code, testing it. So now what? Can it into production? No. It has to go through several environments. So there is something called a staging environment. So the automated way in the DevOps model, right, it would ensure the build, test, and it is deployed to your staging environment automatically. So staging environment, right, since it's a replica of your production environment, the configurations of production will be similar to the configurations. I mean, the staging configurations would be similar to the production. So I can ensure, like, any tester, any quality tester, or any load tests or any performance tests done on the staging where my codes are there, I would get to know in advance. Then something happens in production, I deploy. So that's a where till it goes to the staging, there's like continuous delivery. So you halt there. Once everything is good, your security things are cleared, your management approves, then you go deploy in production. So the phase till this stage is the continuous delivery. But some say, why do I need to wait? I'm very confident that my changes, whatever I did, will be very good in production. There shouldn't be any issues. So that's when continuous deployment comes. So continuous deployment doesn't have a halt. It will right away go from your central repository to your production. So passing through all these stages, build, test, and stage, it will push to production. But the thing is, it will have lot many validations between the stage and the production environment. Like you might have 100 test cases, or maybe more than that. If it's a full module checking, then it will be more than that. So there are some cases where even minor changes in the code would need to go through all these hundreds of validations and then be pushed to production. So there is again a mindset. Either you want to halt at continuous delivery and then go via the approval way to production deployment, or you continuously go your changes to the production. So it all depends on the requirement here. So by automating these, right, till the stage, like you no need to be involved. It will be all automated. So that's how getting your code till stage and production will be automated by the DevOps tools. So there will be a lot of tools that's present in the market to do this particular pipeline. So we can look that further in the later part of the demo. Okay. So now we have covered three circles of DevOps practices. Now let us see infrastructure code. Till now, what we have seen is one side of the coin, the development, the testing, and giving it to release. Now let us see at the other side of the coin, where infrastructure. So infrastructure, right? Your code has to sit somewhere for it to be available to the outside world. So that is infra. So this infra is not a small issue. It should be highly considered. Because, okay, maybe I go into the scenarios. Let me tell you what this infra people will do on a daily basis, on their roles and responsibilities daily. So they are responsible to set up the servers, configure the networking, create the route tables, configure the DB, install your dependencies. Every application, right? If I have a Java application, I need to have those Java dependencies in my server. Else I cannot deploy my software. So that kind of software dependencies, everything will be installed by the operations team. Yep. Okay, so now it's there. Good. Is that all enough? No, right? Yes? Enough, right? That's enough, right? I can deploy my software. So it will be available. Why should I be worried? Okay, no worries. So that's not enough, because they also need to maintain. In case if your server goes down on which your software is present, then who would bring another server in place and deploy this configuration so for our application to be available? So not only that, but also they have to do the DB backups regularly. And in case if they have to update any security patches, they need to update onto the servers on a regular basis, else there would be security issues. So these all tasks, right, they do manually. They used to do manually. So during that time when they were manually doing all these things, right, there is a lot of time invested and effort from the operations team, because it has to be very careful when you have to match two servers with the same configurations. You shouldn't be missing the required dependencies. So there is a time and effort, and also it's error prone because it's done by human. So in order to overcome these, there is something called infrastructure as code. So you saw product writing in Java and all those Java, .NET, Groovy, or whatever it is. So infrastructure also has such tools to write in a document, to write in a way such that those can be executed on multiple servers. So reducing the human intervention. So what all we have discussed in the above slide, right? If you see, there is setup and maintenance. But when I have to consider infrastructure as code, I need to still further split them down into identify what exactly is the issues I need to automate so that it will be easier for me as an operations team. Because by the end, DevOps will only look for a reliable software, reliable product in the market. It shouldn't be impacted by any human or any efforts, any delays caused by the efforts. So strip them down, right? I see infrastructure provisioning as one state, and configurations on the provisioned infra. Like in the previous step on the infra that I provisioned, I need to configure the other things. That as a second stage, and deploy, maintain the things as a third stage. So if you see infrastructure provisioning, so as we discussed before, need to spin servers, networks, create load balancers. So the tool, the infrastructure as code tool that I have should be able to do this when I write some code in. It should, when I execute it, it should be able to spin up the server for me, configure the network for me, and configure the load balancers for me. So I don't need to check has it configured all these things or not, because it's mentioned in the file that it has to execute. So spinning up n number of servers wouldn't be a much issue for me because it takes via the code that we have written. Just running the code would do. And apart from that, this configurations. So the dependencies of the applications. So those all applications can also be coded as a dependencies that has to be installed on top of the service. So when some application team comes to me, hey, I need these things, can you please install? So there is no need to have manual. We can just write that in the script and ensure we run it on them, and that's it. It's up. The dependencies. And yes, in the maintain portion. So the scale up, scale down servers also, I don't need to worry because I have the template ready. So any new server that comes up, it refers to that template and comes up. So there would be a minimal effort from my end in order to ensure that the new server is with the same configurations as the other servers in the group. And deployment, deployment of application on infra. So on the infra now as a developer, I will also have reliability. Okay, the new server, though it's up, it would have the similar configurations, and my deployables, whatever is there, would be in sync with whatever was deployed on the other servers. So the application, right, how the application behaves when it communicates with this server will also be the same how it communicates with the rest. So by there we ensure there is an assurance. So okay, there were certain tools in the market like Ansible, Terraform, Puppet, Chef. So you can go through them later. But let me tell you, as I told you before, right, if I split the stages, then there are certain tools that would support for me till some stages and need to have and some other tools to accommodate me till the continuous deployment of the applications. Because not in general, there will not be any one tool that will accommodate all your requirements. So in conjunction, you need to have you need to use the tools according to the requirements. So yeah, that is where infrastructure as a code helps us in like speedy the process. Okay. Microservices. I know most of you guys might be smiling listening to this because this is a very buzzword. Microservices, Docker, and Kubernetes. Okay. So what is this microservice? Anyone from the group? Any ideas or any pointers?
So what I thought is like these are like small. So we will be using our we'll be having some lot of OSs and all these things, right? So what microservice in my case is like we'll be having some small set of these OS or virtual devices. So we use that to upload our code or whatever it is. So it might be confusing for you to understand my terminology, but that is what I thought. Like these are like virtualized devices for us.
Okay, okay, good. Not a problem at all. I can understand. I can relate to what you say. That is some part of it, but let us see what else it would cover along with what you have mentioned. That's a very good one you mentioned. I'm pretty not sure of your name, but thank you for this. Yeah. So, okay. If you want to go via a scenario, right? Take Flipkart or Amazon. So any portal, they would have a search bar for their product. They would have a catalog list. They'll have my orders, and they would have some promos that's going in the page, right? So all this is giving the final view to the end customer. So there will be several internal modules that would be there to support these things that you see on the site. So microservices, how it came in is previously, even in waterfall model or previous models, what you see, they used to code everything once completed, then only deliver. So even that is, yeah, okay. So that used to be one style. But here now, since it's a very fast moving world, you cannot wait until the whole site is good and it's properly tested and you then ship it to your user. And also the style of writing, shipping your code should change. Modularizing your code should change. So because when you see your application, right, as an executable, uh, all your modules in the code, all your code is in one big block, think as one jar or something. Finally, it will get executed. Okay, onto some, previously it used to be like on desktop, on the client's desktop and all, they used to they used to have these executables installed. Like everything should be packed, everything should be built and tested and then deployed to those desktops. But later on, right, it started like we can't keep deploying onto that end. We have to have a server somewhere where we can deploy all this, but they can keep accessing. Because if any change previously I used to have that deployed on those desktops. But now, since I have a centralized server somewhere that can handle my deployable, so that every client or the customer who interacts with my website, right, they can keep getting my updates faster. So from a view of installing these deployables on the machines, on those desktops, they have come further a bit and was deploying onto some server, which is accessible via internet to all the clients and users. But later on, right, if there is a change in some module, then entire code has to be shipped and updated in the server, redeployed in the server, and re-verify everything. So it is a bit okay compared to the previous, but the thing is, there is certain time that we lose. Code should be packaged, which supports all these modules. Everything should be packaged and should be pushed to the server. So to address this, right, they came there came a breaking of modules, like your code, your requirement is broken into modules, and the development of those modules were handled separately. Like instead a big chunk that you see here in the code project, they started doing in the small chunks. Small chunks, it is good. Teams are doing it fast. Everyone is coding, everyone is integrating, it is good. But still how they deploy to the servers, to that servers somewhere, right? It's still again one single package. So though it's a rapid development, all things have to come into one particular deployable and execute. So there's also some kind of delays that happen because every testing has to be made and all the other things. So then this concept of microservices has come in. So what if these particular modules that's shown as an application, though we have modularized, it's still as a single application. What if we split the applications itself? So module will become application 1, application 2, 3, 4. So splitting them as applications, I can deploy whenever that particular module is needed. So I can ship it. So with Agile, since we start doing the sprint planning and all, I was able to do my code and my application, that particular shopping cart or that particular module is working good. So I'm good to go. I no need to wait for my other parties like orders or the product search to come in along with me. So I can go individually with my deployments. So that's when they services for the deployments. So that's what is micro. Okay. Okay, so the user sees my changes. I'm good. I'm in competition with the market. I'm okay with the emojis or whatever I need to code and push. I no need to wait for other modules to ready. I can push it off. I can get good user experience and all. I'm good in the market. There is something called scalability. So though I'm deploying my executable without depending on others, still the server is same, which is sharing with the other modules. So what happened is, rather it was a thought that came in to split the servers. Like module A can run on certain containerized environment with its dependencies. So it doesn't even need, so if there is a huge traffic or something like a promotion, my promotions page will be dying like anything. So what I as an ops team, as a DevOps team should think, okay, I need to ensure that this particular portion, this really available when compared. So what I do, I'll ensure this module is placed in multiple servers, so that only that can be there and it is fastly available, and even the clients are happy. So then they came in, okay, then we isolate the dependencies that each and every module or the application would need. So in conjunction with the VMs and the, okay, just to take you to the other side, what we are seeing is the application side microservices. So at the same time, parallelly, we are on the infra level. So like the VMs and the Dockers. So we have multiple, okay. Is it okay for you all? Any confusion till here? Okay, I assume it's okay. So Docker, right? Okay. But there, okay, I spin multiple modules of my Docker, of my module in Docker. There between other containers, right? Like the shopping cart or to the product page or to something. I need to have a communication between all the modules. So Kubernetes will help us with several Docker containers. Like your communication is established in case. So with respect to Docker, right, Kubernetes has Docker, I mean uses this Docker, but would additionally have certain layers to ensure like your containers are scalable. Like in case if by something your container is dead, it will ensure, Kubernetes would ensure there is a replacement with another container. So it will give you a reliable application. So it's also, so Kubernetes is also a script, like you can define things like how many containers you should have, is it how the service should be, is it a load balancer or is it what kind. Maybe I won't go in depth of the internals of the Kubernetes, but I would give you a high level view of what Kubernetes is. So it will ensure the scalability of your containers. So you can have this in mind when you keep go any sites on the Kubernetes. So it will ensure there's a network layer, like a communication internally between all these particular containers that's on. Ensuring like there are certain namespaces. Like I have application has some other project also. They would be also hosted on the Kubernetes. So Kubernetes will ensure this is isolated from this. So the communication, whatever happens to my shopping cart is all internal, and it's good, and it's communicable there, and also scalability is there. So there will not be any effect on the other apps that are running there. So it will basically containers for all your Dockerized. So that is my view on the microservices, Kubernetes, and Docker. So, okay. So one of the circle in the DevOps, right, it's continuous monitoring. I've seen is the development portion, the headache that's involved when if there is no CI or the CD, and see how on the infrastructure level how it's improved like that, and on the on the coding, on the microservices level we have looked. Let us see after the deployment. Now what? Is my role ended here? So I deployed my service. Everyone are asking, is it done? Being a DevOps engineer, your role will not end here. You should have a continuous monitoring of the application that you have deployed. At the back end, though your Kubernetes or your Docker or whatever microservices are highly scalable, you should always keep monitoring as a priority. Because monitoring this phase, right, it will tell how your application is performing. You might have huge throughput to your application. Is your application sustained? The infra that you have, is it able to take that particular traffic, or is it able to sustain with the amount of load it takes, it is getting? So all that should be monitored. Apart from that, when I click, when I for me, I should even throw a maintenance page if there is some activity going at the back. At least throw something, but rather than some page, so it should be considered in good competition in the market to be on top of the competition. So you have to have the monitorings also in place. So infrastructure monitoring in depth, if not in depth, maybe I'll give you some view of it. So it will check on the CPU, the memory, the load. You will be alerted beforehand. Something like 99% it is done. Oh no, what should I do now? But by that time already my application might have crashed. So it's important to have infrastructure monitoring. Not just this, but also to know about your process. what's taking up. So there will be a bit of troubleshootings that has to be done as part of a DevOps engineer. So in order to identify the issues that monitoring tools are throwing, so you should be having adaptable to learn this kind of troubleshooting stuff. Also, you should be stretch yourself to go beyond and see what might have occurred. So okay, so that is for the infrastructure monitoring. Application performance monitoring, right? Like how is the application performing? How by depending on the throughput, how is my application? Any delays when it connects to the database, any transactions, how are the transactions that's hitting my site, how are they? Expected, is the response time good from my application? So if you see loading, I'll become a frustrated user of that particular product. So we need to ensure how the performance is also. So that's for application performance monitoring and synthetic monitoring. So this particular synthetic monitoring, right? It will ensure like my abc.com is always available. Like I'm able to see that when I see the page, at least something loads on my page without um, like unavailable or something. At least it's available for me in at least as a maintenance or something. So these were some of the checks as a continuous monitoring we do. So this will be observed before deployment, after deployment, and when expected huge traffic like the now we have Black Friday, so most of the people would be monitoring. So monitoring plays that important role. So in case if need to scale up, ops team would scale the things up. They see what processes, what's happening. So all this is quite important. So we cannot say this particular roles and responsibility takes position higher than the other particular roles. So as a DevOps, we should be able to connect all these particular dots. Okay, so previously what all I explained is like in the concept. So, but this concepts and practices, right, need certain tools in the market. So if you see, there are quite a lot of tools that's available. So as I told, DevOps is nothing but dev plus ops. So here you see this space: plan, code, build, test, and then the ops: release, deploy, operate, monitor. So this whole cycle is like ever running. There is no end for it. So it keeps going, iterations, it keeps going. So there are tools in the market, like for the code, as I mentioned, right? There is source, okay. There is Git, and there will be GitLabs, SVN. There are many such coding source code managers. And for build, you can use Maven, Gradle, the build tools like for building your Java or whatever the applications there are. And for testing, we have Selenium, JUnit, Cucumber, all these particular things. So each and every phase has many tools, but it's up to the team to decide on which tools they should consider basing on the requirements they have. And also a must thing is on the budget. So every tool is costly, so we should also consider that, and as well as the features that every tool gives us. So if you see deploy Docker and operate Ansible, Kubernetes, and yeah, like the monitor, Splunk, Datadog. So all these several tools. If you want, there are a wide range of tools. You can interact with the tool guys personally. You can also ask them, you can also get some interactions with them, know what their tool is, analyze the requirements, and then choose the best tool that fits your requirement. So that is where till the monitor we have. Uh, any questions till now? Is it a bit clear? So if you again come back, right? So all this we have seen. So there is DevOps is not a one tool. It's not a software. It's not a technology. So it connects all these things with all the methodologies. So that's what DevOps is. Um, okay, maybe can we go for a small quiz if you all are okay? Like maybe you can also text in the chat. Anyone in this group, like what did you understand this? What the DevOps is? Like, is it any of this? Can you will it automating the process of software delivery and infrastructure change, or is it the developers taking overall operation tasks, or how it is? Like any guesses? I mean, based on understanding, anyone? Maybe let me downsize a bit. Okay. Anyone can text here. Should be okay. Yeah. Maybe, Satyagaru, maybe you can tell me, let me know if anyone texts any option that they.
One says it is option D,
Option B.
and some other one says it is option C.
Option C. Okay. The ones with option D, can you let me know what's the decision point for this? Maybe.
Yeah, option B by Banu. Okay.
Sorry, I cannot hear. It's a bit low.
Bhanuchandra says it is option D.
Okay. Okay. Maybe the one other who says option C, maybe?
Yeah, Rohit, you can speak.
Yes, ma'am. From starting from the writing code and delivering, every process must take place parallelly to achieve uh, more benefit, like to get into the market and grab the opportunity. So everyone in the team must do their work parallelly. So I think
Right.
my knowledge.
Okay, yeah. So we go with option C because it's a collaborative work between multiple domains here, like the developers and the other IT professionals. So yeah, so automating the process parallelly along with the delivery that we have and the infra changes. Okay, let's go to the other one. Okay. Can you choose the appropriate order, like which you feel, because we have been hearing about various methodologies, right? So can you choose any of the option? Anyone?
So I guess it is like A B C D E F itself.
A, B, C, D, E, F. So do all of you agree for that? Okay, okay, cool. Yeah, you need to plan the procedure first before you implement anything. Make a design out of it, write your code and execute the code, test it in your locals and test it on your QA environments, and then release our client systems and monitor and get the feedback. Yeah. So that's correct. And let's see this, who would answer. So which benefits of adopting a DevOps approach could you be included in a business case to adopt a DevOps approach? Is it improved deployment frequency, which can lead to a faster time to market? Or is it lower failure rate of new releases? What does DevOps address, do you think? Is it a shortened lead time between fixes
I think it should be
or
above.
faster mean time to recovery?
I think it's only above.
I think it's all of those are correct.
Yeah. I think you guys were seriously listening my session. Yeah, it's all of the above. So DevOps will be involved in all these particular, DevOps would give all these particular benefits. Yeah. Okay, that's a good session. Do you, okay. So like if you plan a career, right, in the DevOps, like if you want to have a eagle eye view of the entire, not just software cycle, but also the release and the operations end. So DevOps would give you a career with um, such things. So let us see if you want to become a DevOps engineer, what all you would need to look in, like start looking in from now on. You should have logical thinking to identify any of the issues that you get, or to you should be logical, and also you should know certain scripting languages. Maybe you can start off with shell scripting, Groovy, or Python. Maybe you can just see them, get to know um, how the syntax there is. So doing what would achieve, what is the outputs of certain scripts that you do. Try get a Linux server or a Linux container and start scripting the things, so that even a minor scripts like checking the OS version or anything, start out with certain scripting languages. Try do by yourself, see how you can proceed on. You should be able to have some knowledge into it as a beginner, and you should also know the automation tools. Like you have seen the various tools that we use, right? So specifically for the CI/CD, we have lot many tools like Jenkins, and we have Bamboo, and also we have from AWS also we have Code Pipeline, Code Deploy. So many. So irrespective of either it's on premise side or it's on cloud, you will be given many tools in the market. So just go with the simple tool that you can use, and try create a small practical labs or practice sessions on it, so that you will get used to how it will be, and a bit of knowledge on the networking. So how components communicate. Even you can also look into the Kubernetes. uh, but I don't suggest going to I mean, networking also you should see, but I do not say go depth in it until unless you are familiar with the containers and Kubernetes. Then go for the networking if you feel it's, because it's again a big ocean. Start with containers, Kubernetes, and then get to know how containers communicate along that portion of networking, and then go beyond into the actual networking side. So even for containers, right, you have Docker. So all these things you can install on your laptop. You can pull the images that is available in the GitHub, play through them, do some changes to the Docker files, and you can play with containers on your local setup. Kubernetes, I know it's a bit advanced topic, because you are in the start. But Kubernetes also, right? Instead the plain Kubernetes that you go directly, there are certain other tools in the market, like the Rancher or other tool like the EKS in Amazon. So there were certain tools in the market which you can use, so that understanding them, you can understand what Kubernetes in depth, rather than going once straight away to Kubernetes. Yeah. So just have knowledge on these things, so that when you enter into an organization, you will be at least able to relate the things, and then on in practice, you would be good enough. Yeah. Okay. Maybe before questions, maybe let me take you a quick tour on the AWS. Mm, okay. So, as I told you before, right? Uh, DevOps connects all these particular dots, your development, operations, and yeah. So if you see, right, for a start, I don't say this is a preferred AWS that you also should try in. Since I have an account in this, I'm just showing my AWS account, where you can get your service. You no need to do the hard process. You can do in a better way. So for the compute purpose, right, you have certain sections here by AWS, like compute, storage, database. So even the thing which I told you, right, the CI/CD, the continuous integration and delivery. So those tools were also here. You can give a try. And even for EKS and ECS containers and Kubernetes. Just a second. So you have containers is ECS here, Kubernetes is EKS here. I mean versions of the Amazon. So you can use them, and you can just pin as needed. Available documentations from all the cloud providers. If you feel setting up your server is difficult, you can always leverage on the cloud, but ensure it comes with some cost. Keep that in mind. Yeah. So let me see how code commit would look for the CI section, right? Let me show you the code commit here. So in the cycle that I have told you, right, in this particular presentation, so this particular repo, what you see can be any repo, like any product, GitHub, GitLab, SVN, or anything, Subversion or anything. So you can, for the code commit is the AWS version of that particular component. So you can use this component, create your repository here, sorry, demo 2, and click create. So it creates me a repository where I can directly via the console, I can upload the files. If I have any, I can check in my code here. Else I can write a new file directly, like add file, create file. I can write in the code here. So you can always keep uploading your source codes into code commit repositories, which can work as a source code manager for you. And also you can see for the rest of the components like the build, this whole pipeline, build, test, stage, prod. You can you also have the components like code pipeline. So in AWS terminology, we say it's a pipeline. Pipeline you can create. This is the name of the pipeline I can create. So it will ask me what is your source code, because finally what I want setting a pipeline is to deploy my code into some environment. So it will ask me where is your source code. If I'm using AWS code commit, I choose this and I input the repo name which I created previously and the branch. Since I didn't have any code in it, it's not displaying me. Maybe I can take any other repo like this demo. Master. Click next. So after your code is in, you should be able to build it. So for the build provider, AWS asks you, do you want to go ahead with the AWS code build, or do you have another tool called Jenkins? So I can go ahead with code build. So it will ask me, okay, you can specify the what are the build dependencies you have. So if you want to build a Java application, you would be needing Java dependencies, right? So you need to tell them, okay, I need all these dependencies. After I get these dependencies, run it. If you have Node, you will have NPM dependencies. So you need to install all those dependencies in the build phase and let it run. AWS, right? Here you no need to have some server available for it to build the things. AWS will, this is AWS code build is also a kind of Docker at the back end. So you specify what you need as the dependencies via some YAML file. It will get all those dependencies installed on the code build and it will be available for you. Like I need Amazon Linux 2 operating system on the back end, and the runtime version I'm okay with the standard. And these were specific standards from AWS, which you can go across maybe later. And the environment type is Linux. So I can choose which one, either is a GPU or a Linux. For me, Linux is enough. So I just need to specify, as I told you, right? I just need to give it a file. I have a file called buildspec.yaml that AWS code build will recognize. Okay, this is the file that sits in the source code. Once I see that file during this pipeline, I should be able to install these dependencies like the it's for node npm dependencies and all those things. So and then make the build work. So it's such a thing. It's taking a bit of time. Okay. If you have a server available, right, to deploy your code, you can deploy it. Else, if you only want till the CI, you can halt at this particular process. Means, let me open a duplicate tab. Let me show you the code commit. So this is the repo I was using earlier. So that has some Docker file and some scripts. Previously, as I mentioned, the build scripts, the build specs. So here I will tell if I'm running a Docker, I'll tell what is, these are all the Docker related commands that I need to run in order to execute Docker. If it's Java, you would write in the Java commands here. Like you need to have which version of Java and all that, so that code build will ensure that it gets those versions to build your software. So now I don't have an environment to deploy my software, and I was only looking till the CI continuous integration phase. Means when I commit the code, this pipeline should auto trigger and run the test for me. That's it. I'm good. So I'll know if my code has any issues or not. And this continuous integration and continuous deployment delivery pipelines can be separate. So it's not required that all should be in one particular pipeline. It can be separated because there comes a lot of addings to the pipeline, like security scanning and many things. So it all goes in depth when you actually see the scenarios. So it's not just build, test, stage, and to production. You'll also have something called security scanning on your code and all those things. So yeah, that goes. So since if I don't have any deployment stage, I can skip it. And that's it. I'm done with my continuous integration pipeline only. So as soon as I set my pipeline, it executes one round by itself. Like it will get the code, do the build, and see the test on it if I have any test cases in my repo. So if you see, it's executing. So in AWS, right, you have quite many options. As a fresher, like to understand how the components work, you can check EC2. EC2, what is S3? S3 is nothing but a storage where you can place your dependencies also, your files, apart from the source code, right? Whatever you have some for your website, if you need any static photos or something that has to be stored somewhere, you can use this particular storage locations. It also has the database components which you can see through, like when you get to see any other documentations from AWS, you can use any of these components. You see, it's going to next phase. So I no need to say go to next phase or anything. So it just goes on. If I change something in the code commit, again, it will be re-triggered. So for instance, let me add one more file, create file, test commit. if I commit something, I just committed something into the repository. So let's see if the pipeline is auto triggered. Let me refresh. You saw it has already triggered. So there is an automatic check every time a developer or someone kicks in the code what all you want. So apart from this, if you have any other scripts to run, you can include them in the YAML file, all the checks that you have to do, and it will be integrated to your pipeline, so it can run it. So that's how you will ensure. So previously, if you have seen, it told it failed. So as a developer, when I see it tells fail, then I just see what it says. Why did it fail? Because it couldn't find something. Oh, okay, then I need to have something in my project. So it didn't find this particular build spec YAML. So let me see if I did have it in my code or not. Sometimes it also throws the dependency errors. So that's where you get to know if your code is good, any fixes that you have to do or something. Also, this build spec YAML or giving this way, right? You will be having the same set of dependencies across environments, like your let it be your test, staging, or production. So yeah, so that's how this is a CI integration. So you can keep checking the things here whenever you, I mean, if you have any accounts in AWS, free accounts. Yeah. Okay. Any questions? Like,
Dear participants, please ask if you have any questions. Okay, if you have no questions, then
it's okay. You can text me if you feel. Yeah.
yeah. Thanks for this valuable information, madam. Now we are having a validatory program. So here I'm inviting the participants' feedback and suggestions. Please, if you have any feedback or suggestions, you can make. Okay. If you don't have any feedback or suggestions, so here I'm handing this session to our HOD, Abdulaziz, to convey his message.
Yeah, thank you, Satya. First of all, I would like to thank our esteemed speakers, Mr. Puneet Kumar, Puneet Reddy, Mr. Bhanuchandra, Mr. Satyanandaram, Mr. Praveen Kumar, and Miss Gauri Padmaja for making excellent presentations and making this webinar interesting and meaningful. I am sure that all participants have taken note of all your suggestions and gained benefit. Now, I take an opportunity to thank all our administration, right from Honorable Director Professor K. Sandhyarani, Administrative Officer Mr. Mohan Kishan Chaudhary, Dean Academics Dr. G. Ramesh, and Finance Officer Mr. Sudhakar Reddy for their encouragement and support towards the webinar. My heartfelt thanks to Power Supply Electrical Maintenance Coordinator Mr. Dinesh Reddy and IT Infra Coordinator Mr. Satyanandaram and his team for continuous support to make the webinar success. I thank the HOD IT Department Mr. Gyan Venkat for their suggestions for the webinar. My special thanks to Mr. Satyanandaram, convener of this program, for all his continuous efforts to make the webinar success. Actually, without him, this could not be materialized. He is the person from the beginning to the ending looking after everything. I thank all the department faculty for their suggestions and continuous support to make the webinar success. Last but not least, I thank all the participants attended for this webinar, and I hope all the participants get benefited with this webinar. In future, I hope these kind of webinars will be coming up from the Department of Computer Science with your all support. Stay home, stay safe. Thank you all. So that's it, Anna.
Yeah, that's it. So here I'm posting feedback link.
Yeah, we will send the feedback link through the all your participant email IDs. Please give your feedback through the link from the email.
Okay, thank you.
So thank you all. We are closing this section formally now.